guys, welcome to another video from Unitrack YouTube channel. I am Taruka Kalansurya, BSc Computing undergraduate, and today we are going to talk about linear data structures. So let's move on to my video. So here, as you can see, first when we learning about linear data structures, first we need to clearly understand what is a linear data structure. So here I am going to explain what is linear data structure. So in data structures, we can divide data structures into mainly two groups. The first one is linear data structures and the second part is non-linear data structures. As I mentioned before, today our topic is linear data structure. So as you can see, when we talk about linear data structure, we can define it like this. Type of data structure in which elements are arranged sequentially and each element is connected to its previous and next element, allowing for efficient traversal and access. So here, when we talk about linear data structures, these are interconnected with the elements in nearby. You can see in here, the elements are related to the next element and the previous element. So these elements are as a pack. So let's move on to see what are the linear data structure types. So when we're talking about linear data structure types, we can mainly see four types of linear data structures. They are array, linked list, stack, and queue. When we talk about arrays, a collection of elements identified by index or key stored in a contiguous memory locations. So in an array, they have a specific and unique identity to the location that the data where is located. So this will help to easy access of the data and easy storing of data. So when we're talking about a linked list, we can define linked list as a sequence of elements where each element we can tell them as a node contains a data part and a reference link to the next node. So in a linked list, they store data and also an address. So in here, we can name the element as a node and the address as a link. So when we're talking about stack, we can define stack as a collection of element with last in first out access, meaning the last element added is the first to be removed. As a real world example, we can get a set of chairs. So when we put chairs on another and another, we have to remove the last in chair to access the things. The last in is the first out element. So when we talk about a queue, it is different. A collection of element with first in and first out access, meaning the first element added is the first to be removed. So in the next part, we will talk about array in deep and in detail to clarify what is linear data structures. So when we talk about an array, I have clearly defined what is an array in the before slide. So here you can see in an array, memory is stored in a contiguous memory location. So when we talk about access, we can direct access to element via their indexes. So when we talk about a size, it is a fixed size, must be defined at the time of a declaration. When we creating an array, we need to declare it. So when we declare the array, we need to assign the size of the array. So when we talk about the types, can be of any data type. So array, it could be integer, float, characters and decimals and anything that can be happen to these arrays. So when we talk about the array operations, we can clearly see there are mainly four operations here. They are insertion, deletion, traversal and searching. When you talk about insertion, that we means adding elements as a specific positions. So deletion, removing elements from the specific positions. When you traversal, accessing each element of the array sequentially. When you talk about searching, finding the position of a specific element. So here in an array, we already talked about the address and the location tags. So here using that array locations, we can clearly and we can speedily do these operations like I have described. So as examples, we can see a list of numbers, characters or objects that I have already mentioned that the types can be any type. So here we can store anything in an array. So let's move on to another type of linear data structure, stacks. So in here stacks, you can see I have defined what is a stack, and here you can see access is only the top element can be accessed directly. So in a stack I have already mentioned that this is the last in first out method. So here only the top element can be accessed directly. So in a stack we can see mainly 5 operations. They are push, pop, peak or top, or is empty and is full. So these operations are related with the stacks. So when we talk about a push, adding an element to the top of the stack is we called as it is a push. So when we removing the top element from the stack, we called it as a pop. Where the peak or top we talk about is retrieving the top element without removing it. This is different from the push. It is only retrieving. We do not want to adding or removing the element. We only retrieve the element. So when we talk about is empty, it is checking if the stack is empty or not. Is full, checking the stack if it is stack is full or not. So here you can see some examples for stacks. They are browser history, stack of plates, and backtracking algorithm. So I think you will get an idea about linear data structures. So we will meet with another video on nonlinear data structures. So thank you very much for being with my video, and let's wind up this session, and we will meet with another video with Unitech. Stay tuned with us. So please subscribe me and press the bell icon for get notifications about what are the near updates in my YouTube channel. So thank you everyone.